So while we're sitting here, how do you do the regression graphs? Like the residual or whatever that it was having us do? I'm confused on that when we have, because it's like, do this so you can look at this so you know if it's normal or not or whatever.
I'm going to look it up. Did you do the save function?
I did, but it still wasn't looking anything like what they had. So I watched the tutorial on it too, like for the preparation assignment, and they did everything in Excel.
Really?
Yeah. So I'm like, I thought we were told not to use Excel.
This class just...
Yeah, this class especially, I want it to be over so bad.
Yeah. I'm fine with my other classes. It's this one.
Yeah.
I haven't done the evaluation for this one yet. It's not going to be a very good one.
Did you see that she said she'd give a 3% raise on the overall grade, though, for doing it?
Yeah, I did.
That's
like,
great.
I'll take that 3%.
Heck yeah.
Because it's going to be all I can do to pass that final exam, I'm afraid. Especially with this last bout of stuff. Like, I was okay with last week's lesson, but then today, or this week's, as soon as they talked about, okay, you need to do the residual graphs and all that, but it doesn't tell you exactly how to do it.
Yeah.
So in under 3.3,
okay,
that's where I figured out how to do it.
See, and that's where I went, but it still wasn't looking anything like they wanted it to.
Because mine came out.
I'll have to keep looking at it. I'll have to keep playing with it. I was just playing with the homework assignment to try to figure it out, so.
Yeah. Did you get your stuff all done, Justin?
The pre-work?
Yeah.
No, but I accidentally opened up the quiz earlier, so I kind of looked at it and tried on the quiz.
You have all the right answers.
No, I struggled because it just, I mean, trying to search for everything because I watched the videos too, and then I read through the whole thing, and I don't know why I just have such a hard time with these, but it just seems like they always ask a question that is never in the reading.
Well, I did the quiz for the homework this week, or the homework quiz already, and it asked the dumb margin of error again. And it didn't
my
go over it.
I guess the quizzes would be nice if it was actually on what we just learned, not we're going to take you clear back to lesson 5.
I know.
I can understand the exams being comprehensive, but at the same time, I wish it would be like midterm would have been the first half of comprehensive, and then this last one be comprehensive on the last half of stuff. But it's not going to be. It's going to be the whole entire semester.
Well, because you spend your whole time going over one unit, and then like at least half, if not more, is over the previous unit, and it's just a waste of time.
Yeah. I'm like, I thought the homework quiz was to review what we just went over, not, yeah. I'm getting frustrated with the class. That's why I'm glad it's almost done.
Yep.
The goal is to not bomb the test completely.
Yeah. Yep.
I think if I can at least get a 70%, I'll be good. I'll pass the class.
And then be done with it forever.
Yes. At least I only had to take one math class for this major, so.
You did?
Yeah.
Wow.
This is the only class I had to take that was math.
I've done 2 algebra classes and calculus.
That's what I have next semester. I have college algebra and then trigonometry because they're prereqs for the chemistry classes.
So I did all of those when I got my associates, because I got my associates in generals. So I got all of the math classes out of the road.
Oh, that's nice.
but I had taken college algebra when I was actually at Rick's.
Mm-hmm.
So that one I did pretty good on because I didn't know my husband yet. It was a summer course, and he didn't come until fall. So, and he's like, "Hey,
Well, you guys ready to go?
Yep.
yeah, let's get this over with. Let's get the torture over with."
Yeah.
Okay, lesson 23. Make sure I open the right one. And then we get to start reviewing for the final exam on the last half of the week.
Is it the final or the? Because
It's
we
the
have
last
one more.
exam.
Oh, I thought we had another exam and a final.
No, just one more and we're done.
Hooray!
Or,
That makes
yeah, I was
my day.
looking through because I babysit for my neighbor. And I told her, I said, okay, everything opens up for me to view to see what it's going to look like on Saturday.
Mm-hmm.
And I looked at it and I'm like, you've got to find somebody else next week. One of my classes is a 2-part final.
You.
Yeah. That's when I'm like, yeah, I'm not babysitting next week.
Yeah. So number 3, I selected the third one down. The H of O is beta 1 equals 0. Beta 1 is not equal to 0.
Yeah.
Yep.
And then number 4, a residual is the difference between the observed value y and the value predicted by the regression line.
Yep.
Yeah.
I was just looking at this number 5. A plot of residuals supports using linear regression when, I think it's when you see a megaphone shape in the residuals. I'm gonna go look.
I was looking for that one. I couldn't find it either. I couldn't find it. I mean,
Because I remember reading that megaphone thing, so.
so a
Let's see.
megaphone shape occurs when points tend to be close together. It suggests, oh gosh. If there is a megaphone shape apparent in the residuals, it suggests that the variance of the error terms is not constant for all values of x. It suggests that there's a difference in the spread of the residuals depending on the value of x. So that tells me nothing.
A plot of residuals supports using linear regression when, let's
Sorry.
see.
I believe,
Yeah.
where's
This
that?
residual plot, let's see. Residual plot. A residual plot is a scatter plot where the x-axis shows the independent variable x and the y-axis represents the residuals for each value of x. I'm going to say they're like normally distributed, but I could be wrong.
So here it says if there's a pattern in the residuals, it suggests that linear regression is not appropriate.
Right. So if you go down into the bottom where it says remember, a residual is the difference. Yeah, it just says it's the difference between the observed value of y for a given x and the predicted value of y on the regression line for the same x. It can be expressed as, and then it gives the equation.
Would a megaphone shape be considered a pattern of sorts?
I think so. I'm just going back up to that. There are several patterns that could arise in a residual plot. Curvature, megaphone, and outliers.
Yeah. So I'm reading, if linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. If there's a pattern in the residuals, it suggests the linear regression is not appropriate. So plot of residuals supports using linear regressions.
Regression.
I don't know. That's confusing.
If I would just kind of use the process of elimination, I would lean more towards normally distributed.
Because we talk about that.
because the residuals are positive. I don't think that's right because they can be negative, right?
Right.
And then we
Let's
know
see.
it's not the pattern.
There's 4 of them, so we could do
At least 3.
If a linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter.
yeah.
Mm.
How about the residuals look normally distributed?
Let's go with
Yeah,
that.
let's try that.
And then we'll just go down the list from there.
Yeah, no kidding. We'll
Perfect.
get one of them. We have enough tries, right?
Yep. Okay. For the next 8 problems, wow. Use the data in that math sets. Oh my goodness, math,
Math.
self, efficacy.
Oh, goodness.
Okay. Explanatory is the
My
variable.
dear sweet time opening. Okay, compute the residuals for the data using the software.
So compute the residuals for the data using software. What statement best describes it? So we're going to use the confidence variable as the explanatory. Oh, I wrote that wrong. That's why I'm confused.
So in the dependent, you put score, and in the independent, you put the confidence rating. I just went through that and looked it up in the reading to make sure.
Mhm.
Okay, so the dependent is the
The
confidence
score?
rating.
Oh, the confidence rating is dependent?
Yeah, because it says, let's see, use the confidence variable as the explanatory variable. I'm having your problem now. And the score variable as the response variable. So your dependent is your response and your independent is your explanatory. If I read through the reading correctly.
Yeah, that makes sense.
So then we do this scatter plot.
So because oh, never mind. I figured it out. What do we put in as the x-axis, the confidence rating or the score?
That's
Because I know the y we put the unstandardized.
and then move your independent variable So which one is the independent?
Oh, bother. Our independent is,
The confidence rating, right?
the confidence, yeah.
Okay.
My brain does not want to function. Holy cow.
So I guess let's look at the question or the things now. I would say the residual forms a linear pattern.
Yeah.
Did you guys get your graph to work?
Yeah, that's what I chose too.
Yeah, the residuals form a linear pattern.
Okay. Based on the QQ plot for these residuals, I gotta go do that.
So then we go into analyze descriptive QQ plots. And then I'm assuming we put confidence rating and unstandardized in there. Is that what we do? Or am I doing this wrong?
I was doing the unstandardized and the confidence rating.
Okay.
Is that what you said?
Yeah,
And the understandardized
just
in
in
the
a different order.
Okay, so then it does form a linear. The residuals are fairly normal.
Yeah. We get to do 18 problems. I just looked at that.
I know.
So use the software to create a scatter plot of the data given the scatter plot, residuals plot, and QQ plot. Which of the 5 assumptions about linear regression are satisfied? Check all that apply.
Okay, so how do you do the residual plot? Is that
Well,
the,
didn't we just do that? Do then the graphs and the legacy dialogues and the scatter plot. That's the residual plot.
okay.
Yeah.
Yeah, because I'm like, okay, I have the QQ plot and I have the other one.
So I'm going to select there's a linear relationship between X and Y,
Mm-hmm.
Yeah,
and the variance of the error term is constant.
Would
And
you
then
say the
the-
residuals are normally distributed? Because
that's
if
what I was just thinking.
yeah.
And then the measured without error. And I'm going to, actually, I think it's all of them.
I think so too, as I'm looking at that.
Mm-hmm.
We have a few tries to get it right.
Yeah. Okay. And then
Okay.
the slope
Is that
is,
the 0.042?
yep.
Just a minute. I gotta figure out my things here. Okay, where did I get that wrong? Because it's the coefficients, right? Is what we look at.
Yeah. And it's the one under B, and the score is going to be the
See, and I
whatever
had
slope.
18.690 and 12.695 are my
Hmm.
numbers.
So when you did those, did you put, let me go back in and see.
My dependent variables is the score, confidence rating is the mean, is underneath.
Because I have the dependent as the confidence rating, and independent is the score. So do we have them backwards?
I don't know.
Okay. Because I went off of, I'm pretty sure. Where did I read that now? So your dependent or response variable into the dependent box. So the score variable is the response. And then in the independent is the predictor, so that should be the confidence rating. So now let me look and see how I have that put in.
Hang on a second.
So I have the confidence is my independent. My dependent is the score.
And I have them just backwards. Let me look real quick to the homework quiz because I think that the math one was on there. Oh, no. Well, nope. Okay, let me.
We lost her.
We lost her. We're getting used to that.
Yeah, yeah, it's just normal. That's when I stop hearing her talk. I always go back to check. And yep.
That's me too. I'm like, it got awfully quiet. Is she still there? Or I'm like,
Yeah.
oh, she's back.
I'm back. So looking at the data,
Mm-hmm.
the scores are like between 0 and 100. So I think it is, the way you've got it is right.
Okay. Yeah. Because it says the response goes into the dependent, and it's saying our score is the response.
Okay.
This is probably the first time they've
So-
actually explained which one to put which way.
The slope is 12.695, right?
Right. That's why I'm like, did I do something wrong?
Those ones always mess me up. I hate questions like that.
This one actually kind of told you which way to put it, so I had to go back and see which one was the dependent and independent. Okay, so for the lower bound, I have 10.674.
Yeah, that's what I have too.
Is that, do you just go to the descriptive one and then explore?
It's in the coefficients one.
So when
Oh,
you
I
go to
forgot-
analyze, go into the regression,
I
linear,
just did them all the
and-
same.
and then you go into statistics and you put it in the statistics
Oh,
is
yeah.
when you do it.
That's what I forgot to do. Okay, yeah. 10.674.
Yep. And 14.715.
I think they should let us make the math test a group test.
I know, that'd be awesome.
I mean, we've had some quizzes that we didn't do great the first time together. So, based on the evidence and using a level of significance, what decision would you make regarding the hypothesis test for B1? Fail to reject.
I think it's reject because
P-value is less than A.
the correlation, well, let me, hang on, let me go back
The
over
P
here.
is low.
Did.
Reject the null. Or is it fail? Now I can't remember.
It's
Because the
because
p-value is
it's less
0,
than
isn't it?
it's less than alpha.
Yeah.
Reject the null test because the p-value is less than alpha. And then there is,
Sufficient evidence to conclude that the slope of the regression line is not 0.
No, there's going to be, it's sufficient evidence.
Yeah, sufficient evidence.
Yeah.
Yep.
Like, I'm reading through this. We reject the null hypothesis since p-value is less than the level of significance. There is sufficient evidence to suggest that there is a linear relationship.
Yeah, the bottom one, right?
Yep.
So there is sufficient evidence to conclude that the slope of the regression line is not zero.
Yep.
Okay. Next. These ones always throw me off in which way to put them in.
At least we got a 50-50 chance on this one.
Yeah. So let's see. How did it put it in our reading? The dependent is the body length. The constant is the head length. The head length was used to predict the body length.
So body length?
Yeah, I'm going through real quick to. The predictor is the independence. So the dependent, yeah. So body length, I'm pretty sure. Okay.
Oh, hey, look.
Margin of error.
So I think we should use that subtract the upper from the lower, or the lower from the upper.
These ones are
Just need
the
to
ones that keep killing me on tests too.
Hey, Lorinda, which did you get the margin of error one right in the homework quiz? Did you do that one?
It's the upper minus the lower over
Okay.
2.
Divide by 2.
So I'm getting 0.443.
Divide that by 2. 0.443. Yeah.
Yep.
Now input the lower bound, which is 7.218. And the upper is 8.103.
What can you say?
I think it's the top one. We are 95% confident that the confidence interval will contain the true value of B1 or whatever.
Sounds good to me because we have 2 more chances. Don't overthink it. All right. I'll submit.
Okay.
Keep my fingers crossed.
I wish it would tell us at the top what our score was instead of having to scroll all the way to the bottom.
I know. So we missed 8 and 6.
Is that all?
Yep.
Wow.
What did we get on 8? A 0? Because if you don't get them all right, it just gives you a 0.
Hang on.
Or did it give us a partial score?
It gave us 0.
Okay. So 6 was the other one, right?
Yeah, 6 and 8.
So I would say the top one then, because they're not all negative, are they?
No. Because it talked about how you couldn't have negatives either because it would be silly is what they stated in the reading. So we got 100 on our describe the data from last week.
Yeah.
And I did have a chance to quickly look through the PowerPoint, and that's looking good.
Okay, good.
So we just add as we finish up stuff. Okay. So I'm gonna, let's see. Let's go through these 5 requirements. Linear relationship. Let's see, what you hope to see is a hot dog shape, no pattern in the residuals. Normal error term. Constant variance. X's are known constants. Observations are independent. So how does that? And that's just in that chart thing. Okay, there's a linear relationship. I want to say let's unclick the residuals are normally distributed, because it doesn't talk about that anywhere in those requirements.
The only reason I would support that one is because of question number. Nope, just kidding. Never mind. I think you're right.
Because we have the linear relationship.
Yeah.
We have our normal error term, so the variance of error term is constant. We have our constant variance. X values are measured without error, so that fits in one of those. And observations are independent.
Okay. Yeah, I agree with that.
Just looking at that chart. Okay, I'll submit and see
Okay.
what it looks like. And for the 3rd time, yes, I want to submit it.
That's so annoying.
6 is correct. 8 is still wrong.
This is really stupid. It doesn't even give us partial credit.
So we just got to work on 8.
So which ones did you select for the other time? I cut out.
We did all of them except for the residuals are normally distributed.
Just because looking at that chart. I'm opening my quiz back up. So it's taking a minute. And I might as well fill in those ones. So, I don't know.
I'm going to go back into the lesson.
Yeah, I was just trying to go off of the chart in there. I'm just going to go ahead and put in my answers while we sit here and try to figure this out.
Guys
That
need
was
to go
mom. I
out.
didn't do it. She's gonna get me like this and
Go out.
just like my nerve.
Okay, so there is a linear relationship because it's a hot dog shape.
Mhm. What is the variance of error term?
Really?
Okay. Number 8. I got the other ones filled in. So. So I'm sure we can say that they're all independent. The observations are independent. X's should be measured accurately and precisely. So the X values are measured without error.
Yeah. Let's see.
Would we still say that one? Normal error term. The variance of error term is constant for all X values. For all values of X.
So it says for the normal error term, you should see that points in the QQ plot are close to the line.
Right.
So they are somewhat close, but they're not like insanely close to the line. So
Opening it up here. Yeah, because I see that it's, I mean, the QQ plot, it's pretty close to the line.
I'm looking
Mhm.
deeper.
Oh, goodness.
So the deviation from normal, because there's that outlier on like right at number 6. I don't know what that means though. Observations are independent.
I'd say that they are independent.
Ugh, I don't know.
Okay. No pattern in the residuals. Okay. So the residuals are not normally distributed, and that should be normal. QQ plot are close to the line. I agree with that. No megaphone shape in the residuals. I don't know. Do we want to try without those two clicked? Because I'd say there's a linear relationship.
Mm-hmm.
The X values are measured without error, and the observations are independent. Justin's turn to submit so we can see where we're at.
Yeah.
So did you just? Sorry, I think I lost you for a second. Did you decide on which ones?
I think we're deciding there's a linear relationship. The X values are measured without error, and the observations are independent.
Okay, so those three.
Yeah,
Okay. All right, I'll submit it.
that is as close as I can come.
Still wrong. That's impossible. They don't give you any, because sometimes they'll give you like a certain percentage, and you can kind of figure out that, oh, we need to uncheck one or check one more or something.
Mm-hmm. So did you
Right.
submit it?
Yeah, it's still wrong.
And it puts us at a 94.
Yeah, it's not super bad.
But I'm sitting here going through the requirements. I just don't know. Like bouncing back and forth between the requirements and what the drafts look like.
Mm-hmm. Well, I just submitted it. 1 point is not that big of a deal for me,
Yeah.
but it's frustrating.
Yeah.
Yeah, so I'll go with I'll just submit it again with that same one. Since that's how we messed up.
Try
last time
submitting
here.
it without any of them selected.
Yeah.
I'm going to take the X values are measured without error and leave it as the linear relationship, and the observations are independent.
Okay.
Because worst case